Did you know that almost every mechanical component contains holes? But not all holes are the same. Some holes are used for bolts, some for alignment, and some for precise assembly. In this session, we will understand the most important types of holes used in mechanical engineering. Before studying different hole types, let us first understand why holes are important in mechanical engineering. A hole is a cavity created inside a solid material using machining operations. Holes are mainly used for assembling components using bolts, screws, and pins. They are also used for alignment of machine parts and for providing passages for shafts, lubrication, and fluid flow. Many complex mechanical components such as engine blocks, machine frames, couplings, and gearboxes contain multiple holes designed for specific engineering purposes. Because holes play such an important role in assembly and functionality, engineers must clearly understand the different types of holes used in mechanical design. Next, let us understand how these holes are created in manufacturing. To create holes in mechanical components, several machining processes are used. The most common process is drilling, which produces the initial hole in a component. After drilling, other machining operations may be performed to improve accuracy or add additional features. For example, boring is used to enlarge an existing hole and improve alignment. Reaming is a finishing process used to obtain accurate diameter and smooth surface finish. When internal threads are required, the tapping process is used. Additional machining operations such as counterboring and countersinking create recesses so that fasteners can sit properly inside the component. With this basic understanding of hole-making processes, we can now begin studying the different types of holes used in engineering. In mechanical engineering, holes can be classified based on their geometry and function. Some holes are simple cylindrical holes used for general purposes. Other holes are designed specifically for fasteners, alignment, or special assembly requirements. Common hole types include simple holes, through holes, blind holes, interrupted holes, threaded holes, tapping holes, tapered holes, counterbore holes, countersink holes, counter-drilled holes, spot face holes, screw clearance holes, reamed holes, overlapping holes, slot holes. Let us begin with the simple hole, which is the most basic type of hole used in mechanical components. A simple hole has a cylindrical shape and a constant diameter throughout its length. These holes are typically produced using the drilling process. Simple holes are widely used in machine plates, brackets, frames, and structural components. Although simple in geometry, they are essential features in mechanical design. Depending on the depth of the hole, simple holes can be classified further as through holes or blind holes. A through hole is a hole that passes completely through the thickness of a component. The hole begins on one surface and exits from the opposite surface. Through holes are commonly used in bolt and nut assemblies, where the bolt passes through the component and is secured with a nut. They may also be used for shaft passages, wiring paths, and fluid flow channels. In engineering drawings, through holes are usually represented using the diameter symbol, followed by the word through. A blind hole is a hole that does not pass completely through the component. Instead, the hole stops inside the material at a specified depth. Blind holes are commonly used when the backside of a component must remain closed. They are widely used for threaded fasteners, mounting screws, and machine housings. Many components, such as engine blocks and mechanical frames, contain blind holes for fastening purposes. An interrupted hole occurs when a drilled hole intersects with another cavity or feature inside a component. During machining, the cutting tool repeatedly enters and exits the material. Because of this, interrupted holes create challenging cutting conditions. These holes are commonly found in engine blocks, hydraulic manifolds, and valve housings where internal passages intersect with drilled holes. A threaded hole contains internal threads that allow bolts or screws to be directly installed into the component. These threads are typically produced using the tapping process. Threaded holes are widely used in machine assemblies, mechanical frames, and engine components. A common thread specification is written as M10 by 1.5, where M indicates the metric thread, 10 represents the diameter, and 1.5 represents the pitch. Before creating threads, however, the correct hole size must first be drilled. A tapping hole is the hole drilled before performing the tapping operation. The diameter of this hole is known as the tap drill size. The tap drill size can be calculated using the formula major diameter minus pitch. For example, for a thread size of M10 with a pitch of 1.5 millimeters, the tap drill size is approximately 8.5 millimeters. This ensures that enough material remains for the cutting tool to form the internal threads correctly. A tapered hole is a hole whose diameter gradually changes along its length, forming a conical shape. Tapered holes are commonly used in machine tool spindles and taper pin assemblies. Because of their conical geometry, tapered holes provide accurate alignment and strong frictional locking. Common taper systems used in engineering include Morse taper and other machine tool taper standards. A counterbore hole contains a cylindrical recess at the top of the hole. This recess allows the head of a bolt or socket head screw to sit below the surface of the component. Counterbore holes are widely used in machine frames, structural components, and assembly plates. They help create a flush surface while protecting bolt heads from interference with other components. A countersink hole contains a conical recess at the top of the hole. This design allows flathead screws to sit flush with the surface of the component. Typical countersink angles used in engineering are 82 degrees, 90 degrees, and 100 degrees. Countersink holes are commonly used in sheet metal assemblies, aerospace structures, and machine covers. A counter-drilled hole is produced using a specialized cutting tool called a counter drill. This operation creates a cylindrical recess with a flat bottom. Counter-drilled holes are commonly used in machine housings, fixtures, and precision assemblies where fasteners must seat accurately. In components produced by casting or forging, the surface around a hole may not always be perfectly flat. In such cases, a machining operation called spot facing is used. A spot face hole creates a small flat surface around a hole. This operation ensures that bolt heads or washers sit properly on the component surface. Spot facing is particularly useful in cast or forged components where the surface may be rough or uneven. By creating a flat seating surface, spot facing improves load distribution and fastening reliability. A screw clearance hole is slightly larger than the diameter of the bolt or screw. This allows the fastener to pass freely through the component without engaging threads. Clearance holes are commonly classified as close fit, normal fit, and loose fit. They are widely used in machine frames, brackets, and structural assemblies. A reamed hole is produced using a finishing operation called reaming. Reaming improves both the dimensional accuracy and surface finish of a drilled hole. Reamed holes are commonly used for dowel pins, bearing seats, and precision alignment features. Because of their high accuracy, reamed holes are widely used in precision mechanical assemblies. An overlapping hole occurs when two drilled holes intersect partially inside a component. This configuration is often used to create internal channels for lubrication, cooling, or hydraulic systems. Overlapping holes are commonly found in engine blocks, hydraulic manifolds, and fluid distribution components. A slot hole is an elongated hole with semicircular ends. Unlike circular holes, slot holes allow components to move along one direction during assembly. This feature makes slot holes very useful for adjustable brackets, machine fixtures, and mounting plates. Slot holes provide flexibility and help engineers achieve proper alignment during assembly. In this session, we studied the different types of holes used in mechanical engineering. We explored basic hole types such as simple holes, through holes, and blind holes. We also examined specialized holes including threaded holes, tapered holes, counterbores, countersinks, and reamed holes. Finally, we discussed hole configurations such as spot face holes, clearance holes, overlapping holes, and slot holes. Understanding these hole types is essential for mechanical design, manufacturing processes, engineering drawings, and CAD modeling. In the next tutorials of this playlist, we will start creating these hole types step by step and see how they are represented in engineering drawings. Thank you for watching. Stay tuned for more video tutorials. Don't forget to like, share, and subscribe.